Hello, everyone. Welcome. Today, we'll talk about increasing and decreasing functions, and along with that, maxima called maxima or minima of functions. So first, we'll talk about our goals for today. So we'll be able to determine the intervals in which a function is increasing, decreasing, or even constant, and also be able to determine the relative maxima or minima or high points and low points of functions. So first, let's look over here on the left side, talk about what it means to be increasing and decreasing. So a function is increasing if it's going up from left to right. Okay. This is also similar to think about if you're with slope. If slope is positive, it means the line, for example, a slope of a straight line is going up from left to right. Same idea. Also, then a function is decreasing if it's going down from left to right. Then simply it's constant if it isn't decreasing or increasing. It's just like constant or flat. If the function is horizontal, then it's constant. Now, let's take a look at some examples of this idea. Then we'll also introduce the idea of local maximums or minima values. So let's say let's make up a function. So here are x and y axes. Let's have a function that looks like this. And let's label some of these points. Let's say this is let's say the function ends here and here. Actually, let me make this an open circle. Just oops, well, didn't mean to do that, but that's okay. All right, make this an open circle. Okay, let's say this is our function. Now, let's say this point right here, this is point A on the x-axis. This is point B, point C, and point D. So taking a look at this graph, once again, let's say this is our function f of x. Then let's talk about these different places where it's increasing, decreasing, or constant. So the graph starts right here at A, where it's increasing. Is anywhere it's going up from left to right. And so here, there's only one place where that's true. That's from A, it starts increasing at A, and then it keeps increasing until it gets to point at B, and that's where it stops. So these are intervals in which the function is increasing, decreasing, or constant, always given in terms of the x values. And then also, in terms of endpoints, notice this endpoint is included, but it doesn't matter. What we always use for increasing, decreasing, constant intervals, we always use parentheses. So regardless whether the endpoint's included or not, we always use parentheses. So this is where the function is increasing from A to B. Now, decreasing, where it's going down from left to right. As we see, it starts decreasing at B and then stops decreasing at point C. In the same way, we use parentheses for both. No matter whether points are included or not, we always use parentheses for these kinds of intervals. And finally, where is it constant? In this case, it's constant starting at C. It's flat starting at C and then goes to point D. And once again, we use parentheses. Okay. Now, a function can have multiple places where it's increasing or decreasing or constant, or maybe no places. But in this case, we had all three. So that's the idea. So increasing is where it goes up from left to right. Decreasing goes down from left to right. And constant is where it's just simply flat from left to right. And once again, we always use these intervals always in terms of the x values, or at the beginning and end, and we always use parentheses. Now, let's also discuss local maximum or minimum values. We talk about a function f, some function f, we say is a local or relative maximum at some point C. The function goes from increasing to decreasing from left to right at point C. Okay, so basically it's the top of a hill. And the local maximum value then is the y-coordinate of that point. All right. Then for the minimum, it's basically the reverse. So a function has a local or relative minimum at C. The function goes from decreasing to increasing from left to right at that point. So it's the bottom of a hill. And the local minimum value is the y-coordinate at that point. Okay. Now here we call them local or relative because these may not be the highest or lowest points on the graph, but they're just the highest or lowest points locally. So let's take a look at an example of that. Make another function. let's say we have a function here. Let's say it starts right here, goes down like this. Let's say it has kind of a corner right here, and it continues down right here. Okay, so this is our, let's call it g of x. Doesn't matter. Okay, now it's also labeled a few points. So this is point A, this is point B, this is point C, and this is point D. Okay, now let's see what fits. Now, a local maximum value, do we have one of those? Well, actually, we do right here. Okay, it says the function goes from increasing to decreasing. So this here clearly goes from increasing to decreasing. Now it can be either smooth like a hill or just kind of like abrupt change. That's fine either way. Okay, but we see then we have a local maximum, and maybe I should label values. Let's say that value is, let's say maybe this is at -1 right here. Let's say this is at 5. Okay. So I have a local maximum value, local maximum at point C, or x equals C. And that value within the local maximum value is the y value, which is y is equal to 5. Okay. Well, once again, it's local because it's the highest point around. Okay. Now, let's think about local minimum values. And we have one of those. So local minimum is the bottom of hills where it goes from decreasing, then it starts increasing. So we have one of those at B. So in the same way, we have a local, oops, write that again, local minimum value at, in this case, that's x equals B. But now the local, that's the location, but the local minimum value, the value itself is the y coordinate, okay? Y equals, in this case, -1 with this example. Okay, now, maybe wondering why this point here is not a local maximum value, and this point also is not a local minimum value, because this is the highest point on the graph. This is the lowest point in the graph. And the reason is because this is more of a definition thing, okay? Because the definition of a local relative maximum or minimum value is that from maximum value, it has to go from increasing to decreasing, okay? This one, although it's higher, it doesn't go from increasing to decreasing. It just starts here, then it's decreasing. So it doesn't fit the definition. In a similar way here, this point here is obviously the lowest point in the graph. It's not a local minimum by the definition, because by the definition, we have to go from decreasing to increasing. It has to be a point like that. This one is decreasing, then doesn't start increasing. Okay, so it's not, this is something that has to do with the definition. Okay, so that part can be a little confusing, so I want to explain it. So remember, local minimum, so our function goes from increasing or decreasing to increasing. It can be either smooth like this or a corner. And in the same way, a function has, these has to be continuous. But then here, a local maximum is where it goes from increasing, decreasing, has to be continuous, but either a corner or if you have a smooth curve. Also, one more thing, we use the word maxima or minima, those are plural, okay? So if there's more than one maximum value, we call those maxima. More than one minimum value, we call those minima. Okay, let's look at a few more examples. Let's come down to number, let's say this is number, did I number these? Okay, let's just call this examples. And actually, I have a graph we're going to use. We'll move this down for right now. We're not quite ready for it. We'll look at this one in just a moment. Okay, let's go back up here. Now, so my first example, let's look at a function given by a formula. So number one, let's say we have, in this case, f of x is equal to x cubed plus, so this is a cube, x cubed plus 3x squared. Now, I'm going to do, let's actually go to Desmos. Let's see, I'll just go right here. Okay. Now, I'll also do a graph on our paper, but at the same time, let's just do one like here we can see it well. All right, so here, let's say we have y is equal to x cubed plus 3x squared. Okay, now, here we can also pick out some important points. And also, Desmos will often pick these out for you, intercepts and also maximum and minimum values. Okay, so you see that we actually have an x-intercept. We have two x-intercepts, one at -3 and 0. Then these points at 2, -2, and 4. And then 0, 0. Okay, so what we're going to do is go back and actually graph this on our paper. We can always come back to this for reference. So if we draw this, now actually let me center this a bit more. Okay, this looks something like this. So okay, now this point, this intercept is at -3, 0. This point is -2 and 4. And this point is at the origin. So 0, 0. Okay. Now let's combine all these ideas together we've talked about. Increasing, decreasing, constant, also relative maxima and minima. Okay. Now, so where the function is increasing. Let's abbreviate that. So where is it increasing? Well, remember, increasing means going up from left to right. So here the arrows, remember, mean that goes on forever in both directions. So on this side of this point here, -2, 4, this side of -2, it's always increasing. It's always going up from left to right. Okay. So then where does it start? It starts at -infinity and then stops increasing here at -2. Remember, use the x value. Once again, of course, use parentheses, regardless of whether the point's included or not. Always use parentheses for infinity and -infinity. You notice that's not the only place where it increases. It also increases starting at 0, and then by the arrow indicating it keeps on going on forever, it also increases to infinity. So it's always increasing in this interval. And then in between these, we put the union symbol, just meaning it's increasing either in this interval or this interval. Okay. Now, where is it decreasing? Okay. Decreasing means going down from left to right. So we can see there's just one interval where it is. So starting here at -2, starts decreasing, starts going downhill. And it stops here at 0. So it's decreasing from -2 to 0. All right. Now, what about constant? Well, in this case, this function isn't constant anywhere. Okay. So here we just simply say nowhere. It's not constant anywhere. Okay. Now, let's also talk about relative maximum or minimum values. So we have a local or a relative maximum value. We have one of those at x equals -2. Okay. Because once it's going to be a local maximum, it has to go where the function goes from increasing to decreasing. And the value, the relative maximum value, is the y value, y equals 2. Y equals 4, rather. Okay. Now, then a relative minimum value, we also have one of those. And you can have multiple ones, it doesn't have to be just one, it can be more than one. So here we have one of those. Relative minimum means it goes from decreasing to increasing at x equals 0. And the value of that relative minimum is y equals 0. Okay. Now, once again, those, like the graph we showed a minute ago, these are not the highest and lowest points on the entire graph, but these are relative maximum minimum values, the top and bottom of hills. So think about this being a roller coaster. This is the top of one of the hills, may not be probably the highest point, and the bottom of a hill. Okay. One more thing is talking about domain and range. So what's our domain here? Remember, domain is how far I go to the left and right. So we have to exclude any gaps. There are no gaps in this function. Arrows indicate we go forever in both directions. So our domain is simply all real numbers, negative infinity to infinity. And our range is how far up or down we go. Because we also have to exclude any gaps in the function. This doesn't have any gaps. So the range, in this case, is also the same, negative infinity to infinity. And that's true of all cube functions like this. Okay. Then, so we actually move this down. Let's take a look at our last example. So this is one that has several parts to it. There we go. Okay. Let's take a look at this example. So we want to do the same things, answer the same questions, where is it increasing, decreasing, and constant. And then also answer relative maximum, minimum, also range if we can. Domain and range. So let's take a look where it's increasing. Okay. So it looks like we have more than one spot. All right. So first, let's start from left to right. So it starts increasing right here at -8. Sorry, -8, not negative infinity. Then it stops increasing here in this segment at -2. Once again, always use parentheses. Okay. Anywhere else it increases? Well, yes. So here, starting at 0, then also the section stops increasing at 2. And then it starts increasing here again at 5. And n stops increasing at 7. That's where the graph ends. And like before, anytime we have multiple intervals, we just separate them by the union sign. Okay, that's where it's increasing. Now, where is it decreasing? All right, so once again, start from left to right. It starts decreasing here at -10 and stops decreasing at -8. Once again, always use parentheses for these kind of intervals. And where else is it decreasing? All right, so here's increasing. And also a function can increase and decrease at the same time, so these never overlap. It starts at -2 and stops decreasing, this segment does, at 0. And these intervals are also always in terms of x. And then finally, it decreases from 2 to 5. Same thing, make sure to include union signs in between. And what about constant? Well, I'm going to squeeze this in over here so it's not constant. This particular function is constant nowhere. It's not constant anywhere. If it was, just like in the first one you mentioned, you would include that interval as well. Okay. Now, local maxima could have one, we could have more than one, we could have none. Okay, so remember these are the tops of a hill. All right, looks like we have at least 2. So here and here. So we have a couple. So one at x equals 2. Then the value of that local maximum is y is equal to 6. Okay, that's one. We have one more. Okay, so that one's at x equals, so x, this first one's at x equals -2. I'm sorry, let me fix that. Apologize. X equals -2. We also have one at 2. Okay. More of a corner, maybe, but that's okay. And then the value is 10. The local maximum value is y equals 10. Okay. Now, let's think about local minimum, local minima. Okay. Now, once again, the bottoms of hills, and it looks like we actually have 3 of those. Okay. So from left to right, doesn't matter where we start with, but here the first one is at -8, and the value is -4. Y equals -4. Last one is 0, 0. So at x equals 0, the value is y is equal to 0. And then our third one, we have a third one right here, at x equals 5, and the y value is also 0. It turns out to be 0 as well. Okay. Now, once again, let's recall why we don't include this point here or this point as local minimum maximum values, because this one is only one-sided. So if an endpoint, also another thing, but a true endpoint like this can't be a local maximum or minimum value. Okay, because it doesn't go from increasing, decreasing, or anything like that here. So it can't be a true local maximum minimum value. Only places the tops or bottoms of hills. Okay. Then the final thing is take a look at our domain and range. Okay, so our domain are x values, so the extent of that. This one's nice, so no gaps in the function. So it goes from -10 to +7. Now, in this case, we're talking about domain and range. We do want to include, domain and range is different in the sense we do want to include, indicate whether our endpoints are included or not, and both are. So use brackets for that. So from -10 to 7. Just remember that when we're doing increasing, decreasing, and constant, we don't use endpoints, or don't only use parentheses. And finally, the range. How far up and down do we go? Once again, it's continuous, so no gaps. Lowest point is -4 here, and the highest point is +10, and it covers every value in between. So from -4 to 10, and both those points are also included. Okay, so let's talk what we've learned. So we've learned is how to determine and how to correctly write where the indications, where the places where a function is increasing, decreasing, constant. And then if there are local relative maximum or minimum values, how to indicate those, determine what they are, and then also how to write those, express those. Thank you. Have a good day.